what we have here. So these rocks that are showing here have been age dated somewhere in the neighborhood of about 750 million years. I mean, very, very old rocks. However, as Dr. Rosenberg was noting earlier, there is some controversy over whether or not how these rocks are the time frames that produce these rocks, and that is because of this fossil that was found. So the reason that fossil is causing all of these new questions to be addressed is because fossils are excellent ways of assigning an age to an event. I mean, we can do radiometric age dating. We can try to figure out timing events based on those types of techniques. However, there's always some errors associated with that. So when you find fossils, fossils just really don't lie. And so now they've got to kind of go back and rethink some of this.
How do we know that we got the age of the rock wrong and not the age of the fossil?
Okay.
Well, let's repeat the question. So it's a good question.
Okay, he wanted to know, how do we know that we don't have the age of the fossil wrong, and that we should even be questioning that? So I'll let you.
Well, the fossils have been dated elsewhere in terms of their age by fitting together the relative ages, number one, and bracketing the ages by radiometric age dating. There's other stuff in these rocks that can be dated radiometrically, tiny little zircon crystals in particular that Dr. Barth works on. Sarah's working under Dr. Barth. Zircons are what? Zirconium oxide or silicate?
Oxide.
Pardon me?
Oxide.
Oxide, okay. Yeah. And there are tiny little grains in here that normally they're not produced in a sediment. These zircon crystals are produced in igneous rock, so they must have weathered from somewhere else. But the guys who do the stratigraphy say that the ages of the zirconium crystals give an approximate age to these rocks by various methods they fill around. And then the paleontologist a few miles up the road in a core found a little crinoid, which has to be much, much younger. The classic story of these rocks is that they're late Precambrian, at a time when a giant supercontinent called Rodinia was beginning to split up. And this area here, we are on the edge of Rodinia here. It's splitting up, and we're getting a basin forming here. And actually, somebody can run over there and get some of that black stuff and brown stuff, if you're careful. It's brown shales, and it's kind of, it's not really, it's kind of gritty, and it's also brown sands. So we're in some kind of a depositional basin here, but it's not very stable. And these rocks are classically described as being produced by Rodinia as it breaks up. If they're younger, as the fossils suggest, and that's not at all confirmed, it really puts a wrench in this, you know. Michael, are you familiar with this controversy at all?
No.
Okay. Well, at any rate, these are almost poorly sorted sands and black silts and things like that. So I think, and there are really very few fossils in here. Now there's supposedly some trace fossils called Scolithus, which we've never found when we've been here. Marta has been here with her group from Tennessee, and I think they found some Scolithus. They could be latest Precambrian, but I don't think Scolithus are confined to latest Precambrian. So there's a problem here. But if you get the idea that these rocks are tilted as a result of mountain building, that's what you want to get from this. When were they tilted? That obviously sometime after deposition. And it's believed that they were tilted the first of the mountain building episodes, the Taconian, about 475 million years ago. So as we move to the east, we'll see some changes, and we'll talk to you about them later. Any questions about this area?
What are Scolithus?
Scolithus are trace fossils. They're like tracks or burrows. They're kind of grooves and things like
From,
Scolithus, Skolithh. And from where?
that's the name.
Yeah, that's the name of the.
Just,
Yeah, they're sort of like worm or feeding burrows or
Okay.
something like that.
Okay.
So that they're a trace fossil. It's not a body fossil. It's not a shell. It's not an imprint. It's really just a burrow. Very nondescript.
Yeah, and I know
Yeah.
the burrows. I just didn't know if
Yeah.
it was like a worm or what it was.
You know, like
Fossil.
somebody found some burrows yesterday, the Ordovician burrows. They were spectacular. Lori found them. They were just really some of the best I've ever seen from that area. So, by the way, Emily, did you bring that?
I did.
You did not?
No, I did. It's still in the stone
Oh,
go.
pardon me?
It's still in the stone go. Do you want me to grab
But you brought it.
Yeah.
Yeah, why don't you bring both of those stones? We'll show you, we'll remind you what the crinoid looks like, and also what these little burrows. These are not